Okay, so just because my AutoCAD files wouldn't submit on Solus, I have decided to upload them to the YouTube channel, to my YouTube channel, where you can view these files and see what I've done. So the first one here is basically an object where we had to find um, the distance of a line to get two surfaces. So it was done in AutoCAD and then annotated in PowerPoint. Second one was just a drawing of a house based off of a cardboard model, and then I would get the students to attempt that. This was basically to bring in how I had given an example of the cardboard model, and the students were to go and make their own and basic questions similarly like this to their own design. Then I used this drawing then to find the dihedral angle with both methods, so the auxiliary method and the revetment method. And then, oh yes, this is applying the dihedral angle once again. So finding heights, this is the red circle there to find the heights, getting the dihedral angle, bringing it back in, finding that point. There, this line here actually should be construction line. Okay. So that's applying the dihedral angle, and then this last one here is the skewed lines question. So this also should be, yeah. So this is our level line, bringing this line parallel to one of your points. Same down here, getting point P, I think we called it on the question. Looking along that line, finding the first auxiliary where we see the two lines parallel to each other and looking perpendicular to it to get, having that layer switched on. I have. Oh yes, sorry, I just haven't created them as clearly as I should have. And then that's the dihedral angle between two surfaces. That's the skewed lines question. So that's the AutoCAD, and then SolidWorks. This is an activity which I thought was really interesting. So what you can do is, this is a tutorial on SolidWorks called sheet metal. So you can actually get the students to do it, or you can just basically make it yourself and just show the students how there's a sheet metal function and that there's ample amount of things here that you can do with corners, forming tools, etc. And then when you have your surface or your object made, you can flatten it out into a development. So then the students can see the development of that object, and it shows the fold lines and all the rest of it there. So I just thought that was a fairly useful resource to have when teaching the subject of surface geometry.